Okay, welcome everybody to the UMass Amherst Political Economy Workshop. It is my great pleasure to welcome Fiona Tregenna and Elvis Avenyo to our session today. In fact, I should say to welcome Fiona back to UMass since she earned her master's degree in our economics department. Professor Fiona Tregenna holds the South African Research Chair in Industrial Development and is a professor of economics at the University of Johannesburg. She has a PhD in economics from the University of Cambridge and earlier degrees from the universities of the Witwatersrand and Natal in South Africa. Her primary research focus is on issues of structural change, deindustrialization, and industrial development. She's a part-time member of the Competition Tribunal, where she adjudicates competition antitrust cases, and she has served on a number of high-level boards, advisory panels, and councils. Her co-author, Elvis Korku Avenyo, whom I'm also very happy to welcome today, is a senior researcher at the Center for Competition, Regulation, and Economic Development. Before joining that center, Elvis was a researcher on the Inclusive Digital Model project at the Technology and Management Center for Development in Oxford at the Department of International Development. He was also a Global Excellence in Stature Fellow and Open Air's Queen Elizabeth Scholar at the South African Research Chair in Industrial Development Unit, University of Johannesburg. He has teaching and other work-related experiences from Maastricht University, University of Cape Coast, and the International Labour Organization. Elvis obtained his PhD in Economics of Innovation, Policy Studies of Technical Change and Governments from the United Nations University and Maastricht University, the Netherlands. It is really fantastic to have you here today. I think at times the discussion of the Green New Deal can be very focused on advanced economies, and your paper on greening manufacturing, effects of technology intensity on CO2 emissions in developing countries, I think will make a really important contribution in this context. Thank you so much for joining us. The floor is yours, Fiona and Elvis.
Okay. Well, thanks, Isabella. Really thrilled to be back at UMass, even though virtually, and hoping to visit in person sometime in the not too distant future. Thanks, Isabella and colleagues also just for the invitation to present. It's really an honor. When we received the invite from Isabella, I was really not sure what to present at this seminar, thinking about what might be of interest to colleagues there, whether to present, for example, some of the more theoretical political economy stuff, or some of the things which I've been doing with Carmen. I'm not sure whether she's on the call, Carmen from the department there. We're working together on a couple of papers, including on COVID things. But anyway, I've decided to present something which is a relatively new area for me. I've been working for quite some time now, as Isabella mentioned, on issues of kind of industrial development, structural change, industrial policy, and so on. And I think perhaps a gap in my own work on that, I would say, is linking it to green issues and climate change. And I guess increasingly, I feel it's kind of a moral imperative as well for anyone specializing in that field, as I've been doing, to also look at the connection with emissions and climate change and so on. And really happy to be presenting here with my co-author Elvis, Dr. Elvis Avenyo. We've been working on a couple of papers and projects together, which has really been a fantastic experience for me. So this paper that we're presenting today is currently out as a working paper. And we're finalizing it for journal submission. So we really welcome any comments, criticisms, suggestions, including from people who've been working for longer than we have on issues related to the green transition, Green New Deal, and so on. So let me go ahead and share my screen and kick off the presentation. I trust that that's visible. So what we're doing in this paper is basically looking at the relationship between industrialization and emissions, but looking specifically at the role of technology intensity in that relationship, and with a focus on developing countries. So how we're going to go about the presentation, I'm going to frame the paper with some background on the relevant issues. And I'm going to go just briefly into the literature. I'm going to hand over to Elvis, who's going to pick up parts of the presentation. It's an empirical paper, so we'll go through our method and results, and then conclusions and policy implications. So first, just in terms of background and kind of framing where we're coming from on this topic. I think broadly it's from a perspective that recognizes the importance of industrialization. So this draws on the kind of Kaldorian and structuralist traditions in heterodox economics, associated, I guess, in the developing world, largely with the work of Kaldor. And then, in the developing world, and also from a more kind of policy-oriented perspective, with the structuralist traditions associated with ECLAC and so on. And from this perspective, industrialization is seen as key to the development process. So sort of empirically and historically, recognizing the development path followed by many now advanced economies, and the rapid catch-up experience from East Asia in particular. And then more theoretically, it's a perspective which sees growth as sector-specific, in contrast to the sector neutrality in neoclassical economics. So implying that a unit of value added or an additional job has different implications for growth depending on which sector it's in. And in particular, seeing a special role for the manufacturing sector as an engine of growth. So this is linked to a kind of structural change or structural transformation perspective that emphasizes the importance of the shift in the composition of economies, particularly developing economies, from low to high productivity activities, and that sees a sectoral dimension to that shift. So associating that shift in particular with a role for industrialization. And I think in recent years, we've seen to some extent, well, it's uneven across countries, the reemergence of a focus on industrialization and on industrial policy, including in developing countries. But of course, as you might expect, there's very diverse approaches to this. So, I mean, we've seen, for example, the IMF speaking recently of industrial policy, or at least some people there and so on. But there's a diversity of perspectives and what people mean by industrial policy, and the tools and the goals is quite varied. So linking that kind of perspective and the emphasis on industrialization with the climate crisis and the urgency of this, I think it's increasingly, it's well recognized empirically and from a policy perspective that industrialization is a contributor to emissions. So many countries are facing these dual goals of industrialization and mitigating emissions. But given the relationship between industrialization and climate change, there can obviously be a tension between these goals. So broadly, the kind of perspective that we are interested in exploring here is what is the potential for decarbonizing industrialization? And traditionally, when people think about industrialization, think about kind of dirty industries, smokestack industries, and so on. So is there a path towards industrialization and structural change which is compatible with mitigating of climate change at the same time? And I guess just graphically, there's obviously different perspectives on this. Some people would see industrialization itself as the problem. Other people would be looking more at paths towards green industrialization and green industrial policy. Then in the developing country context, which Isabella also drew attention to in her opening remarks, there's particular challenges both around industrialization and around kind of these dual challenges for late industrializers. So late industrialization, obviously, there's a sort of body of literature around this, Amsden and so on, looking at both what are the challenges and what are the opportunities for late industrializers. And sorry, and yeah, obviously even when we compare industrialization, let's say in African countries today, and some people like Carlos Lopez will refer to late industrialization. It's different from industrialization, let's say in East Asia in the 60s, and different again from earlier waves of industrialization 100 or 200 years ago. And when we link this in particular with these kind of dual imperatives of industrialization and mitigating climate change, one relevant point there is that advanced economies didn't have to deal with the obligation of reducing emissions during their own phases of industrialization. So there was less of this kind of dual challenges. Another aspect of this for late industrializers relates to deindustrialization, in particular premature deindustrialization, which is something I've been working on for some time, and servicification. So I think comparing late industrializers or developing countries more broadly with advanced economies, for advanced economies which are deindustrializing, obviously that can still bring certain problems for them, but they've already reached an advanced stage of industrialization. So even if they're shifting out of manufacturing, as is the reality for probably the last half century or so, the kinds of services which they are able to transition into tend to have different characteristics from, let's say, a low or a middle income country, which is deindustrializing. So for developing countries and for late industrializers, deindustrialization as part of moving towards climate change mitigation is different from advanced economies. And I think the growth imperative is also different. So while in advanced economies, there's obviously reflection on, how much more actually do people need, and do we need to keep producing? But the growth imperative is different, obviously in the case of developing countries, where growth can be a matter of life and death, literally, in terms of hunger, access to healthcare, and so on. Not that those aren't issues in advanced economies, but I think we all recognize that it's different in developing countries, and that's got implications for how to tackle the climate crisis. Linked to this obviously is the political economy and the distribution of costs in mitigating climate change. Who carries those costs between countries and within countries? So still as kind of part of our background, then linking this to the sort of the body of work around technological upgrading and technology intensity. So within the broad approach, structuralist and Caldorian approaches, and around industrialization, there's particular emphasis as well on the role of technological upgrading and technology intensity as part of the structural change and part of the catching up process. So in some way we can see innovation and technological upgrading as key to the kind of micro foundations of structural change, associated with building of productive capabilities, keeping pace with advanced economies, and catching up, improving the sophistication and complexity and diversity of what is produced. And when we look specifically at what's referred to as the medium and high-tech MHT industries, which tend to be obviously closer to the technological frontier, more complex, and better able to serve a role as an engine of growth, usually more R&D intensive, and so on. Also linking this to some of the work which myself and Antonio Andreoni from UCL have been doing on kind of the subsectoral dynamics of deindustrialization. So what we found is that as we know, there's a pretty well recognized inverted U curve of deindustrialization, which is observed internationally. But when we break manufacturing down by technology intensity, we find that medium and high-tech industries, manufacturing industries, typically don't follow that inverted U curve. So they don't follow that kind of deindustrialization path that can sometimes seem although I don't think it necessarily is, but can seem inevitable for manufacturing as a whole. So in some ways, the MHT industries provide a more feasible route of industrialization. And linking this back to the challenges of late industrialization and for developing countries, technological upgrading has a particular role to play in the catch-up process for late industrializers. That obviously is also more challenging to move towards technology intensity as compared to advanced economies. So, yeah, so those broad advantages and motivations, I guess, for technological upgrading and intensity are well recognized. And what we're trying to do in this paper is to bring that in to this relationship between industrialization and emissions, and to say, well, as well as these various other reasons why developing countries might want to move towards more technology intensive production, does it also matter in terms of moving towards a green industrialization path? So just to schematically represent what we're doing in this paper is really to look at the relationship between industrialization and emissions, which is, as Elvis will talk to in a bit more detail in a moment, is well established in the literature, but to bring in the element of technology intensity of manufacturing and look at how does that mediate this relationship, or in other words, how is this relationship different for different tech intensive categories of manufacturing? So more specifically, our research question in the paper is, how do the effects of manufacturing on emissions depend on the technology intensity of manufacturing? And to investigate that, we're comparing the effects of these different tech categories of manufacturing on emissions. And we're doing it for a panel of 56 developing countries over this period. So lastly, before I hand over to Elvis, I think drawing on the background and the framing which I've just gone through, there's a couple of bodies of literature which relate to our paper and which we engaging with here. So one is around the literature on the relationship between industrialization and emissions, largely in empirical literature. Then a second sort of body of literature around industrialization and growth and around technology intensity and so on. And then I think the nexus between these literatures is, and where we're locating our paper is a very small but growing and nascent literature linking these. So looking at the tech intensity of manufacturing in relation to these relationships. So I'm going to hand over to Elvis, and then I'll pick up again a bit later.
Thanks, Fiona, for setting the tone. So continuing with the literature, which I think Fiona has already started with, I think it is important to highlight that there is a growing body of interdisciplinary literature looking at the relationship between economic growth, industrialization, and as well as CO2 emissions. And broadly speaking, these broad strands of the literature are entrenched within two main opposing views. And here we classified them as the sort of the industrialist view as well as the environmentalist view. And the first strand, mainly based on the sort of the assumptions of the environmental goodness curve hypothesis, does find some positive relationship between economic growth and CO2 emissions. And they sort of suggest that the emitting effects of economic growth and industrialization often tends to occur at lower levels of development, and that these negative effects tend to diminish as countries grow. So in other words, countries can grow now and clean up at a later stage of development. And I think it's also important to highlight here that almost all industrialized countries as we have them today follow these sort of growth path of achieving industrialization and of course higher income levels, and now trying to sort of clean up, of which Fiona has already mentioned that developing countries today or the more advanced countries today do not have these obligations when they at the earlier stages of industrialization. And also we do see now that there is this particular growth path is problematic, given that emissions are global and irreversible. that after a certain limit, developing countries in particular are very much more vulnerable to the immediate effects of climate change. So there is sort of a policy action that is required in sort of facing some of these challenges that climate change poses. And understandably, there is a critic based on the ecological theories, which mainly argue for the need to protect the environment against the damages of industrial activity. And this perspective critiques the very foundation of industrialization and argue mainly for degrowth, where economies or countries do not focus or discourage the focus on growth and production as well as sort of consumption. And in recent years, we've seen some balancing views between these very strong opposing views in the literature. And these balancing view mainly focuses on how to mitigate the environmental harm caused by industrialization by recognizing the dual economic goals that Fiona has already highlighted in the introduction that would possibly enable countries to grow sustainably. And we do see some growing push towards industrial development, which of course tries to generate productivity, growth, and jobs, particularly in developing countries, but as well trying to do this sort of sustainably. So in these sort of strands, we do see the green industrialization and green industrial policies. And what comes to mind now, of course, is the Green New Deal and the European New Deals coming to mind. That tries to build some global consensus, policy consensus, that tries to foster transformation, of course, in the production and consumption processes as we know them currently, but as well trying to compensate for some positive global externalities that emerge from green technologies and green goods, as well as trying also in this main process to still achieve economic ideals of growth, decent employment, using these greener technologies. There are realizations now that this is not an easy task, of course, and we've seen it particularly in the US over the last 4 or 5 years, as it touches various dimensions of things people believe strongly in, and it includes tech changes, it includes political interest and differences. But of course, now it includes COVID-19 and the recovery plans and how countries aim to recover from the sort of the negative consequences that we are experiencing from COVID-19. So on the main empirical literature, there are, of course, a wide range of literature on some of these issues, specifically on the determinants of CO2 emissions. And this is quite extensive. So we identified two main approaches that are widely used to analyze the determinants of CO2 emissions. And the first one, as I've already mentioned, is based on the environmental Kuznets curve, the AKC model, which focuses mainly on the relationship between economic growth and CO2 emissions. And the main results that are coming out that's pretty standard in the literature is that there is an inverted U relationship between economic growth and CO2 emissions. In other words, as I've already alluded to, countries can grow now and clean up later. And there is also another empirical strand that mainly focuses on the relationship between other economic factors like population and industrialization. And this body of literature, mainly particularly looking at industrialization and CO2 emissions, finds a U-shaped relationship between CO2 emission and industrialization, indicating that lower levels of industrialization are, of course, associated with lower CO2 emissions, whilst higher levels of industrialization is associated with higher levels of CO2 emissions. And we do see now a body of literature growing or coming up indicating that this relationship is particularly influenced by the level of development. And that as countries become wealthier, they pollute less and clean better through intensive investments and efficient production consumption processes. So this relation tends to be sort of reversing as I've already discussed. So what we try to do in this paper is to follow, for instance, Chi and Lin, and these later literature that I've already discussed, by adapting both the EKC models and the step-out models through the inclusion of some key economic variables that we think are relevant that often tend to be missing in either one of these approaches. And as well, to uniquely examine the relationships that we are trying to look at. And some of the key variables that we introduce here, of course, include renewable energy use, fossil energy use, the tertiarization of the economy, particularly measured by the share of services, and as well as trade and other key economic variables that we identify to be very key in these conversations. Next, yes, thanks. So our main contribution here is to sort of examine the specific effect of manufacturing activity disaggregated across two main tech intensities. We consider here the composition of manufacturing value added, where we are able to, the data allows us to decompose this into low tech, medium and high tech manufacturing value added. And also we're able to decompose in terms of exports, low, medium, and high tech. And our analysis is sort of based on these decompositions. But of course, in the basic regressions, we try to sort of test the existing evidence first before we go on to these extensions. And as well, we also examine the nonlinear relationships as we see emerging in the literature between growth and as well as industrialization. I think it's also important to measure that we employ two main measures of CO2 emissions that we identify in the literature that we think are very important and analytically and in terms of policy. And they're mainly the CO2 emissions per capita and CO2 emissions in kilotons. And finally, in terms of estimation, we employ the standard dynamic panel estimation procedures by Rilano and Bond, and we use the GMM step 2 estimator. Well, thanks. So equation 1 here shows our basic specification, where we regress the log of CO2 emissions in country I and in time T or year T on this lag, which shows the dynamic paths or sort of some path dependency of in CO2 emissions. But as well, we do have our log of GDP per capita in constant 2011 US dollars and in square term, and as well as our share of manufacturing in GDP and in square term, following sort of the step-out model that I've already discussed. And our ZIT here is simply a vector of all covariates that we controlled for in the model. And these sort of are the sort of key economic variables that I've already mentioned and discussed. So in the standard model, we decompose and examine our different tech intensity measures on CO2 emissions. So equations 2A and 2B here separately regress and compare the effect of low tech manufacturing value added and its square term vis-a-vis the medium and high tech manufacturing value added and its square term on CO2 emissions. For exports, as shown in equations 3A to 3C, we separately regress and compare the effect of the low tech manufacturing exports, medium tech manufacturing exports, and high tech manufacturing export, and their square terms on CO2 emissions. And of course, we do maintain similar explanatory variables in across all specifications, so that we can easily compare how these variables span across models. Yes. So briefly, this table shows the OECD classifications of industries according to their degree of technology intensity that we employ in the paper. And we do see high-tech industries and to some extent medium-tech industries are at the frontier of technological progress and have the potential to stimulate sustainable production and as well as sort of consumption paths. And we can already see arguably that some of the classifications in high tech employ very sophisticated technologies, while medium tech employs some sort of medium level technologies. Of course, it is also important for us to mention here that there may be some industries in high tech that may essentially be based on very sort of low tech sort of production. And I think, but generally, we argue that sort of the high tech tends to be very complex and less emitting than the rest of the two classifications that we show on the table here. So in terms of robustness, we've conducted different sets of robustness checks. And as I've already mentioned, we use two measures of CO2 emissions, but as well, standard, we estimated that the fixed effect and random effects. And as well, also employed different categories of our measures, particularly our key measures in terms of the shares of GDP in total manufacturing, in contrast to the manufacturing value that we used in our main results, as well as total exports in GDP, in contrast to the manufacturing exports that we used in our main results. So in terms of data, we use two main sources. One mainly from the UNIDO, on the competitive industrial performance data, we use the CIP, and of course we use the World Bank development indicators at the WDI. So we do use the CIP database mainly as our base, or as our parent database, which covers mainly 150 countries over a period of between 1990 and 2016. And our data set that we use covers 56 developing countries, as we've already mentioned, 13 from Africa, 16 from Latin America, 8 from Eastern Europe and Asia, as well as 18 from mainland Asia, excluding Central Asia. Yeah, so this figure here is simply a graphical depiction of the evolution of CO2 emissions in kilotons. So as I've already mentioned, we use two measures of CO2 emissions, the kilotons and the per capita. So these does show in some selected countries. So these suggest that we do see China being the largest producer of absolute volumes of emissions. And we do see South Africa and Brazil having low volumes of CO2 emissions, as depicted here. We do see a different picture emerging for CO2 emissions per capita. We see Russia and South Africa being the leading emitters of CO2 emissions in per capita terms. China is ranked third, overtaking Argentina in 2005. And as would be expected, we do see low and lower middle income countries, Ethiopia, Nigeria, India, and Vietnam, having the lowest emissions per capita out of these sample of countries represented here. So some emerging evidence from these charts shows some heterogeneity in the two measures of emissions that we are employing the data and in the paper across our selected countries. And these suggest sort of a different paths or different carbonation paths. And the charts do also suggest that there are more industrialized countries tend to sort of be more CO2 emitting than otherwise. All right, so main baseline results. We do see here the overall effects of manufacturing value added measured in percentage of GDP on CO2 emissions. And we use both the linear and the quadratic specifications, but as well as we do show results for both the CO2 emissions in kilotons as well as in metric tons per capita in columns 3 and 4, while the kilotons are shown in columns 1 and 2. So the first main result we do see there is the power dependency of CO2 emissions in kilotons, in both the kilotons and per capita terms, with us having the lag term being very significant and positive. Also, we see the share of manufacturing total value added, measured by the manufacturing VA, which is value added, does have a significant effect on CO2 emissions in terms of the kilotons measure. And we do see also these, the square term being negative and significant. And of course, so what the implication of this here is that we do see some non-linearity indicating that emissions fall at a decreasing rate with more industrialization. And this fits quite well with the AKC model, where we also do see here an inverted U relationship between manufacturing or industrialization and now step-out model between industrialization and CO2 emissions. Our results are also very consistent with the AKC hypothesis that countries in early stages of growth tend to be higher CO2 emitting, but these countries sort of eventually fall off at higher levels of development. And this result is confirmed in both when we use the CO2 emissions in kilotons, as well as the CO2 emissions in per capita terms. And of course, we control for other variables in here. We do see that the private sector credit helped in mitigate emissions. Growth in urbanization worsens climate crisis, particularly in CO2 emissions. And we do see that growth in the civic sector, which is sort of a tertiarization of the economy, and the use of renewable energies mitigates emissions. And of course, fossil fuel, we do see fossil fuel strongly influencing higher levels of CO2 emissions. Thanks. So as we've probably highlighted across the presentation, one of our key contributions is to analyze the relationship between tech intensity of manufacturing in both value-added terms and in export terms on CO2 emissions. And we've also indicated that we are able to, the data allows us to decompose value added into low tech and medium and high tech, whilst in terms of the export, it allows us to go even a step further to decompose our variable into high tech, medium tech, and low tech separately. So in terms of the results, columns 1 and 2 report the different results for different measures of CO2 emissions, particularly for the medium and high tech value added equation, and as well as its square terms. And the columns 3 and 4 report that for low tech and its square term. And we do see both the linear term and the quadratic term being significant with a U-shaped relationship. Whilst we do see, in contrast, in terms of the low-tech value-added manufacturing, as sort of an inverted U relationship, where we do see the linear term being positive and significant, while we do see the nonlinear term, the low-tech, being negative and significant. And all other results remain the same in terms of the controls that will be included in this specification as well. And another primary contribution, as we've indicated, is our analysis of the various decompositions of technology intensity in manufacturing exports on CO2 emissions. And we are able to do this because the data allows this particular sort of granular level of decomposition. So in this table, we report in columns 1 and 2 for the different measures of CO2 emissions, the high-tech export specifications, whilst columns 3 and 4 report that of the medium-tech export specifications, whilst for columns 5 and 6 we report the low-tech specifications, low-tech export specifications and its quarter. And we do see here that both the linear and the square terms for low-tech exports are positive, indicating higher shares of low-tech manufacturing in total manufacturing exports leads to higher levels of CO2 emissions, and at an even increasing rate. And for both high-tech and medium-tech, we do see the linear terms being negative, while we do see the quadratic terms being positive. And this is consistent as well with the earlier findings, particularly in the manufacturing, when we use the manufacturing value added shares in total manufacturing. And the observation here, we can see from, I think I can use a highlighter here. No, okay. So the main difference here we do see roughly is the fact that between the high tech and medium tech manufacturing exports, we do see some lower levels of emissions as compared, particularly between the high tech exports and the medium tech exports. And we do see, of course, also the positive effects of low tech, underscoring the evidence that emissions are often conditional on tech intensity in manufacturing across, across categories of tech intensity. Next slide, please. Okay, so in sum, these findings suggest that tech intensity does matter, particularly for CO2 emissions. And in terms of policy actions that Fiona would be discussing now, these issues are important, particularly for developing countries. Fiona.
Thanks, Elvis. I'm going to wrap up the presentation from my side. So firstly, in this slide, we're just trying to kind of summarize take-home messages and what really matters from the results that we put up. So here we just want to compare basically the three sets of regressions that we ran. Firstly, our baseline regression, which is similar to what's already established in the literature. So basically looking here at, I mean, these are just schematic representations, not actually parameterized. On the x-axis here, we're going to have manufacturing value added share of GDP, and here the emissions intensity. So consistent with the literature, we find this positive inverted U relationship. Then in our second set of regressions, we broke down manufacturing value added by technology intensity. Here the data only allowing us to break it down into two categories, low tech and then a combined medium and high tech. So we find for low tech being consistent with for manufacturing as a whole, but actually even a stronger effect on emissions. So in other words, being dirtier than for manufacturing as a whole. And we find the relationship being really different for medium and high tech. So here we find that the higher the share of medium and high tech manufacturing, either in total manufacturing or in our robustness check in GDP as a whole, the lower our emissions. And then in our third set of regressions, we broke down manufacturing exports into the three categories of tech intensity. So here we find for low tech a positive relationship, but here actually an increasing positive relationship. And then for medium and high tech, pretty much the same as for value added shares. So in other words, the higher the share of medium or high tech, either in total manufacturing exports or in a country's total exports, the lower the emissions, and the effect being even stronger for high tech than for medium tech. So just coming to our conclusions, I mean, in our baseline, as I said, we confirm this nonlinear positive relationship, and we find that tech intensity does matter for emissions. It varies considerably by tech intensity across all the three categories of tech intensity in the case of exports and two categories in the case of value added. It's robust to both of our measures of emissions, to different measures of tech shares, and also to our robustness check in terms of different estimation methodologies. So in terms of what we're kind of trying to contribute through this paper is providing evidence on how technology intensity matters for the industrialization emissions relationship, and with a particular focus on developing countries, or developing and emerging economies, which I think have been neglected in this literature. And then, we're trying to make a little bit of a methodological contribution as well at the same time. In terms of policy implications, I think that the findings probably underscore the need for coordination and an appropriate mix between industrial policy and climate policy to achieve growth and development that's sustainable in all senses, environmentally sustainable, but also can support growth and catch up from developing countries. So we see technology upgrading as one of the ways for developing countries to navigate the partial tension between these dual imperatives of industrialization and mitigating climate change. But of course, we hasten to add that we recognize the challenges and complexities of this sort of developmental path. For one thing, it's certainly no silver bullet. So high-tech manufacturing is still emitting. It's just less emitting than medium tech and in turn low tech. And that moving towards more technology intensive industries is obviously just one strategy for decarbonizing manufacturing. So here we're really just talking about the composition of manufacturing. But what matters is not just what you produce, what you manufacture, but also how you manufacture it. So any manufacturing can be done in a less carbon intensive way. Low tech manufacturing can be done in a more decarbonized way. So here we're really looking at the composition, but obviously there's different production techniques to be used throughout. As part of the challenges and complexities that we want to draw attention to, it's also that technological upgrading itself is obviously not straightforward. So it's all very well to say, well, the regression results show that more tech-intensive manufacturing is more environmentally friendly. But if it was that easy, developing countries could have done this a long time ago. So obviously it requires significant effort, significant investment in not only human capital, but in technology and more broadly in upgrading productive capabilities. And there's a range of very real constraints to these, particularly in developing countries, barriers to entry, various political economy factors, both nationally and internationally, skills constraints, limited domestic markets for more high-tech manufacturing, which in turn can constrain kind of using the domestic market as a base for exports and so on. There can also be a trade-off between this kind of technology upgrading and employment creation through industrialization, particularly of low semi-skilled workers, and particularly in the short term. In the medium to longer term, the hope would be that with productivity and technological upgrading, that even if direct labor absorption were to fall, but that can be employment creating in a broader sense, but it might not be for the same workers, and there's also a time issue. And especially for low-income countries, rapid technological upgrading is obviously particularly challenging. The constraints which I've just mentioned are even more binding for low-income countries than for middle-income countries. And the alignment with the profile of the workforce and the needs for employment creation even sharper. So just lastly, just to mention some of our thoughts for future research. We're still hoping to get more disaggregated MHT manufacturing for value added to mirror that which we have for exports. We're also thinking about more of subsectoral analysis. Here we do it by tech category, but I mean perhaps investigating for specific manufacturing sectors, perhaps different measures of technology intensity. As Elvis mentioned earlier, the OECD classification which we're using is obviously very broad and has its limitations. So for example, food manufacturing is classified as low tech, but increasingly a lot of food manufacturing is actually done in a very high-tech way. So as with any of these classifications, it's quite a broad brush. It's not possible for this kind of aggregated national and international data to do it by firm. But we were still interested in looking at sensitivity to different ways of classifying technology intensity, and also looking further into the economic channels. So as I said, we have this as a working paper and preparing it for journal submission. So really welcome any criticisms, pointing out flaws, or suggestions for what else we might do. Thanks very much.
Thank you so much, Fiona and Elvis, for this broad introduction to this conundrum and this very careful analysis of the relationship between energy intensity and CO2 emissions in the developing context. As I've written in the chat, if you have questions, please post stack in the chat and I will call upon you so that you can address the questions directly to the speakers. I actually had one question, if you don't mind, which is, it seems that your results speak to this big debate over industrialization strategy as, for example, expressed in the Ha Chun-Chang, Justin Ifulin debate and the question of leapfrogging. And it seems like you are adding additional pressure to really aim for leapfrogging if one wants to develop in a green fashion. And I was just wondering how you see this or how you see the broader implications of these findings for industrial upgrading strategies.
Shall we go ahead with that in the meantime?
Yes, and while you're speaking to that, I will moderate the chat and call upon everybody who has posted there.
Let me kick off and then welcome Elvis to add on that. Yeah, I think that's an interesting point, Isabella. I mean, that debate between Justin and Hajun obviously brings out the different focus on how dynamic comparative advantage can be, and how far ahead you can push things. I think for me, both theoretically, empirically, historically, it's clear that if you're moving really incrementally, you're not going to achieve the kinds of catching up that is required for developing countries. But as you say, that is already, that debate and that kind of an emphasis is in the context of the long-standing debates around technological upgrading, capabilities, industrial policy, leapfrogging, and so on, but without any attention there to green issues and green industrialization. I fully agree with you that once we bring in this angle, as we're trying to do here, it actually adds additional impetus to the need for less incremental changes and perhaps to leapfrogging. As we say, of course, there are practical challenges with leapfrogging, it's about a careful industrial policy to look at what is feasible and how far you can push the envelope.
Thank you. Elvis, did you want to add to that? Or shall I?
That covers me, but I think a point I would probably just want to add would be that while the catching up process, I think it requires technologies and advanced technologies to produce and consume better, particularly in developing countries. These technologies do not fall from heaven, right? So it also brings sort of to the discussion various other issues in terms of intellectual property rights, who owns these technologies, and how developing countries can actually adopt and adapt some of these technologies in the face of catching up. And I think that also brings a question that already in the chat regarding on needs, whether this catching up process, I'm just thinking here, this catching up process and the linear catching up model is required by developing countries at all. It's just an open, probably question that I'll leave there.
Thanks so much. Isan, you had a question? Isan, are you there?
Hi, yes. Thanks so much for the presentation, both Fiona and Elvis. Just two comments. One is just that, as I said in the chat, just a question about whether, because I mean one of the focus of the study is trying to find whether the composition of the process actually contributes to the CO2, and I was wondering, as I say in the chat, whether another kind of check on this, a useful check on this, would be just to look at the kind of scientific kind of the emissions associated with the processes, and I see there's a link from Adam Hirsch in the chat. I don't know if there are very big complications with that, or something else that would make that not feasible. But it just seems, because of course, in the regression kind of analysis, there are all sorts of confounders and things that might cast doubt on that kind of relationship. And so it's could be maybe an interesting robustness check. And then the second comment, just wanted to get your thoughts on, especially for, and sorry if this is a little bit outside of the field, but in terms of kind of one of the problems that is often associated with this kind of tension that exists is especially for countries that are kind of already on a certain development path, and the question of kind of switching towards these more, as you say, high-tech development, manufacturing industries. And I would love your thoughts specifically for South Africa and the kind of challenge that South Africa faces exactly on this question.
Fiona and Elvis, would you like to respond to that?
I'm not sure if I got the specific question. I think from the first point, thanks for the suggestion. We'll definitely look into that further and the micro evidence on that. I didn't get the question in the second part.
Would you like to briefly pose it as a question?
Sorry. I mean, my limited understanding of the tension, especially for South Africa, is that, but I think it perhaps maybe generalizes to many other developing countries, is that once you're on a kind of path and might be on a low-tech kind of manufacturing path, or in the case of South Africa, some kind of like the kind of mining complex and further down, it's hard to switch towards these high-tech value-add paths, which are obviously is the ideal, as you put it, because it kind of resolves this tension between the emissions and increasing GDP. Wondering if you have thoughts on that transition.
Okay, thank you. And let me add that Isan is a PhD student here in our department.
Yeah, I know him. Thanks. Yeah, look, obviously there is path dependency and so on, but this is what industrial policy is for, right? At least part of what it's for, to say, well, perhaps the sectoral composition of the economy as a whole and the sectoral composition of manufacturing is not necessarily the most desirable one. And how do you, through a combination of tools, push and pull it in a more desirable direction? And that desirability could have different dimensions. Labor absorption, particularly for a high unemployment economy such as South Africa, contribution to balance of, I mean, yeah, policy. It's a policy choice as to what you prioritize. But I mean, yeah, we would obviously emissions is part of that, and not just linked to tech intensity, but you know, just the absolute level of emissions from any subsector. So yeah, it's not easy, but I mean, countries do bring about these kind of compositional shifts. You can use finance, you can use incentives, and so on. But I think that kind of strategy, yeah, it's not just, as I said, about the sectoral or the subsectoral composition. It's also about incentivizing cleaner production technologies across the board. So it's not to write off any sectors as just dirty industry and leave it at that. But that even the dirtiest industries, whether they be low, medium, or high tech, how to support and incentivize cleaner production technologies is obviously a key policy imperative.
Great, thank you. Elvis, did you want to speak to that question at all?
Yeah, it's a small point that just expanding on Fiona's, indicating that there is a need for sort of deliberate policy actions, and this is also required in all structural transformation and industrial policy approaches, right? And particularly for South Africa, we do know that the mining industry or the mining sector dominates. So there is a need specifically for diversification into sort of more high-tech industries that other factors can support, right? In terms of investment, in terms of human capital, and in terms of natural resources in order to sort of man some of these new industries. So I think if there are no traditional sectors that can transition into high-tech, cleaner sector. I think there are options for, more green new industries that can sort of try to drive some of these old industries into, or very traditional industries into a more cleaner production processes.
Great, thank you. Next, we have a question from Maria Nicolaidi. Maria, are you there?
Hi, thank you for your presentation, Fiona and Elvis. I'm curious to get your view around clean energy specifically and how it fits into the green industrialization agenda, both from a technology and industrial policy perspective. Did your research consider any aspects of alternative energy use within the technology intensity analysis?
Thank you.
You want to go ahead?
Yeah.
Want to have a first part?
Yeah, thanks, Maria. So I think it's a great question in addition to the previous ones. So what we did is simply to consider the decomposition between fossil fuel and renewable fuel. So we'd probably say that the renewable fuel sort of covers clean energy, right? And the way we considered green industrialization or tech intensity is the fact that we see tech intensity or more high-tech manufacturing value to be much more cleaner or greener. What we didn't do, frankly, is to specifically identify what combination, the combinations of tech intensity, like higher levels of tech intensity and cleaner energy use. So probably an approach we could use is try to see if we can find some interactions and see if truly our high-tech industries use cleaner energies. And I think that could probably give us a more in-depth analysis and more cleaner response, particularly to this question. But I think it's an interesting point that we should look at. I'm not sure what Fiona thinks.
Fiona, would you like to follow up?
Nothing to add to Elvis.
Okay, thank you. Then we have a question from Christina Wolf from London, I guess. Christina, are you there?
Yeah, hello. Hi, I'm here. First of all, thank you for that very fascinating paper and all of this evidence you've produced. So I think essentially you've already answered my question in the process of answering other questions. So my point was basically just to perhaps refine the policy conclusions a little bit, because if we think about it from a global perspective, some goods are still needed and need to be produced, and some of these goods include low-tech sectors, or in low-tech sectors. I think in your low-tech sectors, for instance, you had food and beverages or clothing. Like, these are still goods that we ultimately need. And so, there is a reflection to be made around, what are the possibilities to incentivize cleaner technologies in those sectors. So that was just my suggestion, to include that into the policy conclusions. Another thought that I had was around the transportation of exports, because you've got exports in your regressions, but there's obviously the question by which means are these exports transported in the international market? And for instance, is there a way to include that in a policy discussion, say for instance, using low carbon or electric vehicles and so on, or rail transport. Yeah, that was just a thought. Thank you.
Thank you. Did you want to follow up on this, Fiona and Elvis, or?
Yeah, maybe just briefly. Well, yeah, thank you, Christina, for the valuable comments, and I think we might also use them to refine the policy discussion in our paper. The last point which you made about transport is interesting, and I think I mean, the transport and how things are exported is not part of our analysis. But broadly, I think it would actually amplify the findings in the sense that high-tech exports would tend to generally be higher value per volume. So when one factors in the emissions associated with the transport of them, well, I suppose obviously it depends on how they're transported, but I'm guessing intuitively that the transport would be less emitting per unit of value added, but we might think about that a bit further. So thank you for the comments.
Thank you. Elvis, did you want to also make a comment on this, or shall we move on to the next question?
Yes, a quick one. I think the second part of the question is quite interesting, and brings to mind that if these high-tech products are produced with high-tech technologies and they are transported with a very high-intensive means of transportation, how then does it balance sort of the initial objective, right? And this also sort of brings to mind how these very technologies or these very high-tech technologies are produced. It's also possible that these high-tech technologies are produced with very high CO2 emitting technologies before they themselves become less emitting. And I think these are very important issues that are not part of our current analysis, are not part of the current paper, but are worth sort of thinking about more broadly.
Great, thank you. Next, I have Joshua Butlander. Are you here, Joshua?
Yes, yeah, hi. Thanks very much for the presentation. I had two questions. The one was about, so I completely understand the focus on developing countries, but it seems to me that it's like, I wonder if you'd thought about extending the analysis to including some developed countries at some stage, because it seems to me that when you're talking about the environmental Kuznets curve, except for the stuff on like the medium tech and high tech, you mainly have one side of the Kuznets curve. You don't seem to have, like, the analysis does not discuss that much of like when countries now, that these like developed countries are going to now reduce emissions. And I was wondering if you have expectations. I mean, because I know, for example, like the US or Germany or Japan are like very big emitters, right? And I don't know, maybe I don't know anything about their industrial base really. Maybe that is low tech. But I was wondering if that would be another way of like either strengthening the story or maybe like casting like some questions about like some specificities and how it interacts with other things about these countries. And then the second question that I had was I was wondering whether this like theory around low tech, medium tech, high tech kind of manufacturing and its relationship to emissions looks at like the global supply chains, because I can imagine that a lot of like high tech manufacturing relies on low tech manufacturing as inputs into production. And that may pose some challenges for saying we need to switch to high tech or whatever. I mean, as I think it was Christina mentioned, some low tech manufacturing is important, but it also may kind of affect how we think about the kind of, if the US is relying on a lot of low tech products, maybe we should think about the US also as emitting quite a lot because it requires those inputs into its production.
Thank you. Elvis, would you like to go first this time? Or Fiona? I can't hear Elvis.
Yes. I think the first part of the question is sort of covered by our square term that assumes that countries like are into the future in terms of their development path, right? But I think I completely agree that maybe also very interesting to look at countries that are already there, right? In terms of developed countries and how that stage of development sort of affects their CO2 emissions. And that also probably comes back to the second question regarding the fact that there is a growing literature that sort of indicates that developed countries often tend to even export emissions, right, to developed countries by allowing them to produce their very crude goods that are more CO2 emitting, and whilst probably they export these goods and they add the final value to it that are less emitting. So yeah, I think these issues are important, and it's something we can discuss to see how we can improve on the paper in this sort of aspects.
Thank you. Fiona, did you want to add?
Yeah, to add briefly, yeah, thanks, Josh. I think your first point is interesting, and it's still a relevant relationship to explore, even for developed countries. Our interest here is, I guess, in late industrializers in the developing world and so on. But the role of technology intensity in mediating that relationship is still relevant, obviously, for advanced economies. Interestingly, even for the sample which we have, which includes emerging economies, we do see a bit of the downward slope of the inverted U curve. But obviously the parameters will be different for advanced economies. And yeah, the point around supply chains and kind of taking a value chain perspective to this, I think is really spot on. From a kind of policy perspective, when we look at emissions, as you exactly point out, what's relevant is not just what's directly produced in a country and kind of holding a country to account to that, but the entire value chain of production, as well as consumption needs and imports from that. It also brings to mind the need to avoid a kind of fallacy of composition argument, that not all countries can follow the same kind of changes in sectoral composition. We could think about the feasibility of bringing this kind of analysis into the data, into this analysis, if we were to use kind of maybe the TIVA data, the value chains data and so on. I think here we're looking specifically at emissions intensity directly from different tech categories of manufacturing. So even if we don't do this empirically, it will be important to reflect on it in the narrative. So thank you for the insight.
Thank you. I still have a number of questions, so I suggest that I will now collect 2 questions and then hand it over to Fiona and Elvis every time. So I start with Shingye Chisoro Dube. Are you here?
Hello, everyone. Thank you, Fiona and Elvis, for your presentation. My question focuses on the different industries and their relationship to exports. To what extent are the stringent export requirements of medium and high-tech industry serving to act as a discipline for those firms to actually invest further and upgrade into even cleaner technologies versus the lower tech industries that are exporting but still have a positive relationship with their CO2 emissions?
Thank you. Barish, would you like to add your question?
Yes, thank you for the presentation. This is actually an area that I'm not really quite familiar with, but a couple of questions came up during your presentations in my mind. And one is that, what are your insights about this relationship that you got, which is low tech, so-called low tech technologies like food, paper, and so on and so forth. If you are increasing your share in manufacturing share in those areas, you are emitting less, at least up to a certain point. But in some medium and high tech, I'm sorry, in low tech you're increasing, but in medium and high tech you keep increasing the CO2 emissions up to again a certain point. And how that really, what are your insights? How can you relate? How can you write a story, come up with a story about that? Specifically focusing on the single industries like manufacturing industries. The other thing, if the focus, other question that came up was if this is a shared story, right? Okay, so developing countries should go ahead and increase their manufacturing share, high tech and medium tech, and who is going to end up with low tech? And I don't think developed countries will be those countries. And these are the questions I just wanted to see how you will respond. Thank you.
Thank you. Fiona or Elvis, who would like to go first?
Elvis, do you want to go ahead? Whatever you prefer.
Yes, thanks, Shinge and Baris, for your questions. I think on the last one, I believe even if developing countries sort of improve their tech intensity in their production processes, there will definitely be this categorization of countries where some still fall way behind whilst others are still leading. So there'll still be some at the frontier whilst others will still be lagging. So in terms of food, for instance, increasing the tech intensity in food production might just simply involve increasing the technologies that are used in plowing or in cultivating or in storing food. That doesn't mean that these raw materials are going to be produced, but they're just being produced better. And of course, that also leads to sort of less CO2 emissions. That doesn't mean that Korea, for example, would stop producing chips, sort of microchips that use probably more high-tech sort of technology. So I think these distinctions will still be there and these classifications will still be there, but probably things will just be done much better with technology. I think that would be the short answer I would give. Okay, so Shinge, so if I understand the question correctly, I do understand that there are restrictions, particularly in terms of international trade, on export of goods, and particularly they are increasing with the climate change policies and protocols being implemented. There are a drive towards companies sort of in the global value chain dealing and probably sort of obtaining products from other lower tech companies that are much more sort of abide to the climate regulations, I would say. So I would say this is a tough one. So there's actually a policy by the EU that is restricting, or that just implemented, that sort of restricting or probably imposing regulations on lower developing countries on as to how they produce, for instance, citrus. So increasingly, we do see that developing countries will be pushed to try to produce some of these products more efficiently using higher levels of technology. So I think with the push towards reducing climate change, I think all global value chains will become more cleaner, not necessarily in the production of low tech, but also in the production of medium tech. I think I'll leave it there. I'm happy to sort of have this discussion with you later, but I think I'll leave it there.
Thank you. Fiona, would you like to follow up?
No, happy to leave that one there.
Okay, thank you. Then I have questions from UMass colleagues Mwangi Waginti and Gregor Siminio. Mwangi, would you like to ask a question?
Sure. Thank you very much, Fiona and Elvis, for a really interesting paper. My question is not directly related to your actual results, but some of the constraints you suggested in terms of the strategy. And so I was wondering, so it calls for a little bit of speculation. I was wondering if you've thought at all about, or if you might want to think about or discuss whether some of your constraints that you face, both in terms of raising resources of all kinds for high-tech production, the different needs of different countries at different levels of development, the needs for markets, and issues of path dependency, whether, particularly in the case of Africa, a regional perspective or a regional industrial strategy might alleviate some of these concerns. I know there are all the difficulties with regional things, so we don't need to say that, but in an ideal world, would a regional approach rather than a national approach be a way to alleviate some of these concerns? Thank you.
Thank you, Mwangi. Gregor, would you like to ask a question?
Yeah, sure. Thank you. Thank you very much for this interesting analysis. I think it's really insightful and helpful in this bigger debate. But I also wanted to ask a question which kind of doesn't directly relate to your analysis, so sorry for that, but I wanted to hear your thoughts. I think a lot of analysis in this space kind of looks at the outputs of the manufacturing industry and their energy intensity. So for instance, do you manufacture electric vehicles, which could in principle be powered by low carbon electricity, or internal combustion engine cars that run on gasoline, so are inherently polluting? And I think a lot of the data that these industrial classifications, you cannot really distinguish these. So I think a lot of people have trouble constructing these green manufacturing sectors nowadays. But I still wanted to ask you, using your data, if you think about these outputs, and in future, probably, an important question for competitiveness globally is whether a country can link its manufacturing industries into these low carbon products or not. Whether your analysis and your sector classification, whether once you look at these low carbon products rather than inputs, would it change anything about the attractiveness of these high and medium tech as opposed to low carbon industries? Or do you think, all manufacturing sectors have the same potential to produce also low carbon outputs in the future? Thank you.
Okay, thank you. Elvis or Fiona, who would like to go first?
Let me maybe kick off here. Mwangi, thank you for the comment. I think the regional perspective is definitely relevant here. Given everything which we know about the small domestic markets of many African countries, and the constraints that those pose for building a vibrant industrial base. So I think the recent developments around African continental free trade areas are relevant in that regard. That's kind of the optimistic thinking behind it. Having said that, I think the execution and the nature of industrial policies in different countries and their prior conditions in terms of industrial structure are going to strongly mediate the actual outcomes of that by country. As with any kind of regional liberalization of this nature, there's always a danger that the countries with weaker and more nascent industrial sectors, those sectors can actually be weakened rather than strengthened, and be swamped by manufacturers from South Africa and other stronger and more industrialized regional economies. So anyway, that's a broader discussion which we're happy to take further. Maybe just the last point which I would add, tangentially related to your question, which I think situates it in the broader context of development paths for African countries, is that in one of the other papers of Elvis and I, we explore the relationship between innovation and export performance amongst in African countries at the firm level. And we find a two-way relationship between these, where countries that innovate more, it helps them to kind of learn to export and improves their export performance. And at the same time, through exporting, firms can kind of learn to innovate. And I think, not so much that the details of our firm level analysis there, but perhaps it links in with this broader issue around development paths for countries. I think the technological upgrading, innovation, and the building of productive capabilities are all linked with export performance, and not just to reduce things to that. And again, it comes back to the need for perhaps supranational approach to regional markets. Maybe I will leave Gregor's question to Elvis. Maybe I'll just say congratulations on your recent paper, which Isabella Kandi shared, and I think it has some bearing on our own analysis. Yeah.
Thank you. Elvis, would you like to chime in?
Yes. So briefly, I think the text sector classifications that we used from the OECD simply classifies these industries by their levels of technology, right? So we sort of pushed the argument, the conversation, using, of course, available literature to sort of say that the more high-tech the industry is, the more likely it's expected to be cleaner, more productive, and probably more diversified and complex, right? So there is no specific model, or there's no specific, I think for now, we haven't seen it yet, that there's a specific way that links or that tries to map sort of tech intensity with green sort of production processes. I think that could be one thing that I think should be interesting to do. Yes, but I would say that it's likely that all manufacturing industries have the potential to improve their tech intensities and probably to reduce some level of CO2 emissions. But of course, it's not all industries that will be able to reduce their CO2 emissions as much as some could, right? So there will definitely be some disparities in terms of the level of emissions across industries, of course. I think it'd be very important to also recognize some of these heterogeneities. And I think one of the limitations that Fiona highlighted is the fact that we were unable to do this sort of analyze some of these heterogeneities due to data limitation. And I think that is definitely a gap that could be looked at in the literature. Briefly on Wangi, yes, I think the regional policy frameworks of like sort of policy drives, particularly in Africa, it's being recognized. We do have the AU Agenda 2063. We do have the AFCTA now. So we do see, or we do organize like sort of these regional groupings to sort of try to forge some of these industrial policies. But it's also a different thing having these regional frameworks and also how they are implemented, right? So these are relevant, of course, but when they are better implemented or managed or probably put to use, they'll probably be much more effective for industrial policy of the member countries, I would say.
Great, thank you. In the interest of time, I'll take one last question by Leons Nidikumana of UMass. Leons, would you like to ask a question?
Yes, thank you very much. And again, nice to see you, Fiona. I wish it was you were here, and good to meet you, Elvis. Thank you very much for an excellent presentation. I hope all researchers are listening, especially dissertation aspiring students. This is you opening a really vast area of research. I have just 3 quick questions, some touch on some other things that other people have said. Now, once you have a quadratic specification of your model, my first question is, what is the turning point? And where are, say, African countries located, on the downward sloping part of the curve, or are they on the upward sloping part of the curve? Because that has implication of whether they should even worry about pollution, if they are already polluting, but they are still not yet polluting, in which case they can continue producing. The other is about the way the data is structured. Technology actually means product. And it seems that improving technology means abandoning your product and moving to another set of products. So that's a very difficult message if you're talking to, say, the government of Ethiopia, and you tell them that they need to improve technology by abandoning leather. I don't know whether they're going to listen to you. So is there any way of thinking about technological upgrading within sectors and within products? Because I imagine there is a way to improve the technology for making leather. Just and a point I used to make, I used to make also regarding to sources of energy. There is a way, certainly some types of energy sources are more polluting than others, but is there a way to generate electricity from coal with more improved technology that reduces emissions? Because again, it's not very helpful to tell a country like South Africa that they should completely, immediately abandon coal because they need to produce electricity. The other last question is about manufacturing versus industry. So if you're talking in your text, you talk about industrialization, then you talk about manufacturing. But in the case of African countries, manufacturing is very, very small. And in fact, in some of them, it's declining. So when you talk about industry, it's really not industry that's transforming. It's natural resource exploitation, it's construction, and so on. So do you take that into account? If you want to really link this to economic transformation, then you have to also think about what exactly are you talking about when you talk about industrialization. And the last one is about the excellent point made by Baris about what does it mean for the international division of labor. That means that some countries are going to be stuck in the low-tech industry, and if we're going to abandon those tech industries to minimize pollution, what kind of path do they have to reach the high-level technology industries, given the governance, the international governance of the global economy, like WTO rules and all that? Thanks again.
Thanks so much, Leons. Fiona and Elvis, this is also your chance for any final remarks that you might have.
Okay. Let me maybe start. Thanks, Leons, for the very kind comments on our presentation, as well as for the really fantastic and tough questions. In terms of the turning points, yeah, I think the shapes of the relationships are what we kind of tried to summarize in that summary slide. So although, for example, it's an inverted U, we find the sample located in the range that we were illustrating there. So, for example, we find for low-income countries that not low-income countries, for low-tech manufacturers, a positive non-linear relationship. So they're located in the upward sloping part, whereas for medium and high tech, it's in the downward sloping part of the non-linear relationship. But we might have to, in our paper, specify those turning points and also look at the location of different regions in relation to those, as you suggested, which also has important policy implications. I think the issue around technology intensity being here treated in terms of the composition of manufacturing is a very fair one, and it relates as well to the last to the last comment which you made. And I guess to some extent it's an inherent limitation of tackling this kind of question through the empirical strategy which we're using of cross-country analysis, where the emissions is basically it's using national data, country level data. So to look at tech intensity, we really have to use, unless someone can come with a better idea, but we really have to use this really crude proxy, which is tech intensity in terms of the composition, the sectoral composition of manufacturing, with all of its limitations. So, for example, if we were doing a firm level analysis, we would be able to look at levels of technological advancement within the firm. And some food manufacturing firms are incredibly high tech, and some chemical firms are incredibly low tech. And whereas I think chemicals is classified as a medium tech sector, but we then wouldn't be able to match that with the emissions outcomes. So it's definitely a limitation of this kind of cross-country empirical strategy. And it means a very crude proxying of basically the composition of manufacturing. You know, obviously there's a long-standing literature and policy discourse around this, and there's different classifications, the Lau classification and so on, but all based on the subsectoral composition, as we're doing here. So I think it doesn't imply countries stopping manufacturing what they are manufacturing, and particularly for countries which are trying to gain a foothold in the industrialization ladder. Obviously, you have to find what is feasible, where those countries have a comparative advantage, even if it would be dynamic. Ethiopia is not going to have a comparative advantage tomorrow in high-tech medical technology or in aerospace manufacturing, whatever. So, yeah, I think from a policy perspective, it's important to take a nuanced approach and to combine this sort of compositional approach to tech intensity with technological upgrading and cleaner production technologies in whatever a country is manufacturing. And I guess from a broader kind of structural change perspective, and maybe this links in with your third question around manufacturing and industry. From a kind of structural change perspective and Kaldor and structuralism and so on, what matters is manufacturing. It's not industry as a whole. It's not to say don't mine and don't have utilities and construction and so on, which obviously they play different roles in the economy. And it's not to say that those are not important. But in terms of the kind of engine of growth thinking, it's associated with manufacturing specifically and not industry. Although we speak of industrialization, but it's really the manufacturing sector which is of interest from that perspective and which is our focus here. Let me leave it there and hand over to Elvis. And no parting comments from myself, Isabella, except to say once again, thanks again for the invitation. And I'm going to try and download the chat here because there was a lot of great comments and suggestions made there, which we're going to definitely regroup on and take on board. So thanks very much to all the colleagues.
I'll make sure to share the chat with you. Elvis.
Yes, I think Fiona has responded quite well. So no additional comments there. Other than to say thank you very much. And of course the audience as well for the invitation as well for listening in. Yes, we enjoyed ourselves. Thank you.
Thank you so much for joining us. I think this was a really, really great presentation, followed by an equally amazing discussion. So thank you everybody for sharing your comments and questions. There was one question that I didn't get to, but I will share that with you in the chat, as I've said. Next Tuesday will be the last political economy workshop of the term with Robert Brenner at 4 p.m. So I hope that many of you will join us again. But let me thank Fiona and Elvis once more for joining us. This was wonderful and was really great to meet you both, even though only virtually. Let's hope there will be a chance for you to come to UMass and to meet in person. I would like to take you out for a coffee or dinner now, but that unfortunately we're still remote. So thank you so much, and thank you everybody for joining us.
Thank you.
Thank you.